Hey there, and welcome to the Audrow Nash podcast. Today we're diving into the fascinating world of robotics with a guy who's making robot arms work in the most unexpected places, from the vast expanses of space to the strawberry fields right here on Earth. I sat down with Dave Coleman, the Chief Product Officer and founder of PickNik Robotics. Now, Dave's not just any robotics expert. He's someone who's been deeply involved in the ROS, or Robot Operating System, community, and his company has become a pivotal player in helping over 110 companies harness the power of robotic arms for diverse applications. If you're curious about how robotics can revolutionize industries like agriculture, aerospace, or even your local restaurant, or if you're just a fan of innovative tech, this episode is for you. So buckle up, grab your favorite snack, and let's explore how Dave and PickNik are pushing the boundaries of what robots can do in our everyday lives. Let's get started. Hi, Dave. Would you introduce yourself?
Hey, this is Dave Coleman. I'm at PickNik Robotics, and I've been a long-time ROS advocate and someone in the the robotics ecosystem. I got my PhD in robot motion planning back in 2017 from CU Boulder. And yeah, I guess that's me in a nutshell.
Mm-hmm. Now, tell me about PickNik, some of the details just for context of the company. So you said you guys are in Boulder. How many people are you? When did you guys start? And then high level of the business model. So how are you guys getting money, I suppose?
Yeah, I'm really glad to be being interviewed by you again. I love this every couple of years.
Yep.
So you've heard this before, but PickNik, we're kind of a delayed spin out of Willow Garage in some ways. There was certainly a couple years gap where I was still in grad school, but essentially Willow Garage back in Menlo Park, Silicon Valley, started the robotic operating system, and one of the projects was MoveIt. And I was actually an intern back then, helping develop the first version of MoveIt. And after Willow closed, it was in the hands of SRI for a minute, but it kind of got dropped from there. And then I picked it up on behalf of PickNik Robotics, leading this open source project. And from there, we've grown a lot. We've helped over 100 companies now, maybe 110 probably. Just do more with robot arms. It's deceptively hard using robotic arms for a lot of classes of applications beyond traditional industrial automation. And so we've been through a bunch of iterations since. We're at 30 people now. We've gone up and down. But we got just a great team of engineers, PhDs who understand how to combine motion control, kinematics, computer vision, and then most recently machine learning into a comprehensive solution that just a lot of companies really benefit from, and we love partnering with other robotics companies.
Awesome. Now, tell me some of the ways that manipulation is hard. What are some of these challenges that are not obvious for why manipulation may be so hard that you guys are working on very often and helping these companies with?
Yeah, so part of my theory on the industry of robotic arms is it started with maybe the 70s with automotive, and then it grew into general manufacturing. And so a lot of the incumbents have gotten really good at serving those needs. And those needs don't actually align with a lot of the newer, more modern applications of robot arms. We basically want to get robot arms into every part of our life. Small businesses, restaurants, your home. We want it to be outdoors in farm fields. We want it to be in hospitals, in space, building our next lunar colony, which is a thing that we actually are under contract with NASA for.
Super cool.
Subsea, supporting infrastructure for oil and gas underwater. Just there's so many areas that I think people forget about, and they just think we have an assembly line, we have a conveyor belt, and we're palletizing. We are machine tending. We are welding parts of a car. And so these incumbents I referred to a minute ago, they've done a really good job of serving this kind of more blue collar warehouse factory space with the classic stuff that people always talk about, teach-pendants and PLCs and all those things. And of course, Audrow, you know a ton about this. You work for a similar company, so I'll acknowledge that. But we actually a term that we kind of borrowed from academia and that we are trying to push forward is unstructured robotics is kind of the niche that we're looking at. So I think most robot companies today, they're still looking at the biggest market, which is manufacturing and logistics. And we certainly have customers in that space that we're working with. You can see some of the logos on our website. But our main focus really is, these next gen applications. Like we had a big program picking strawberries outdoors in California in the farm fields. That was a really rewarding process because there's a tractor driving and arms hanging off and things are very dynamic. You got the dirt bumping and even the seasonality of like the shadows from the sun change throughout the season as the earth rotates. And all those things, they have these big impacts on your machine learning models and you have this like data drift. And that's just like one use case. It's pretty wild the number of things that we've been able to help with. So we're really industry agnostic. We just like hard problems that maybe aren't so served by hard coding waypoints.
Mm-hmm. And so the traditional factories that we think of when we think of robotic arms, where they pick up huge metal and they repeat the same motion over and over again. So that's not the use case you're serving. You're serving unstructured environments where things change, the world changes, the strawberry is not always in the same position, these kinds of things. What in the unstructured space of robotics applications, what are some of the like classes of problems that you see? So you mentioned the environment changes, like the sun moves over the course of the year. What are some of the other ones?
I want to clarify there are actually still plenty of hard problems in manufacturing that
definitely
that are barely solved or just starting to be solved, like wiring harnesses, for example, or assembly is a big one, or just high mix, low yield, low volume manufacturing, like
high mix, high volume kind of thing.
Yeah, high mix, high volume. Thank you. And so
very exciting area.
We do get pulled into some of those. A big area we've been helping out with lately is like in big spaces where you don't want fixed work cells, but you actually want like mobile robots. An example is like a hangar for aerospace, for like large planes. You want actually robots that can drive around. And when you have a robot with an arm on it, suddenly you have to deal with a lot of calibration issues and understanding where you are with respect to the work piece and the work and the tool that needs to be. So there's a lot of like scan and plan. I do think I missed your original question, Audrow. What was it again?
The classes of problems that you may encounter in a structured environment.
And you mean unstructured?
Unstructured, yes.
Yeah.
Like a few categories of problems that you're often helping customers with.
There's one category, it's just like pick and place, which can be a very simple thing if you have a conveyor belt and you make sure that all the parts are coming in kind of in the same exact position. But I mean, that is such a huge term that we have to really, when someone says we want pick and place, we have to ask them like, well, what kind? Because like, okay, let's say we focus on bin picking and you have a bin of parts, and this is again more like warehouse logistics. There's just so much variety to even that one of like how chaotic are the parts in the bin, how exact do you need to place? Because a lot of times people just want pick and drop. That's a lot easier because you don't have to worry about like where you've picked it in your hand. And then there's the question of like, okay, if you have various products that you're fulfilling, let's say your Amazon warehouses, how many SKUs are you supporting? If it's like a single SKU bin, that's a lot easier than if there's multiple.
And a SKU is like an inventory code, right?
Correct.
Okay.
Yeah, every industry has their own terms, but SKU is a common term for
I have no idea what it stands for, but I kind of know what it means. Do you know what it stands for? I've asked in past interviews and I haven't looked it up.
Nope.
Okay, so you have different SKUs.
Yeah.
And the SKU might be a different object. I suppose a different SKU is a different object.
Yeah, so that's an example of a thing we might do. But in other environments, you want to like drive up to a table and move a tray from one work, like automation islands. I've heard of this term, like where you have different machines and you want to do this machine tending. And that's a different kind of like pick and place because now it's a little more structured. Maybe this tray has little slots where you put each product in and it kind of slots in, or the machine needs a certain format of that. So there's just such a wide variety. And then place itself, if you're just placing onto a flat surface, that's easy. If you're inserting it into a particular, like a peg and hole type of problem, like you're having to pull in all this force torque control to make sure that you exactly get it aligned. If you're assembling, maybe you need to hold and have a secondary arm kind of attach it with some kind of welding or screwing operation. So there's just such a wide variety, and we're taking on the really hard problem, and you probably are familiar with this problem too, of a generic toolbox that can do all of these things, regardless of industry. So like we say yes to the hard stuff, like bring it on, we'll take it. And a lot of robot companies, they have arguably this is a strength, but they're really focused on one thing and doing that well. And we're going after the broad stuff. So when there are things that haven't really been solved before, a little more novel, that's the stuff that we get excited about, or it's more dynamic or changing environments, or has a lot of sequences and steps.
That sounds really awesome. So it sounds fun to work on all the different, diverse, challenging problems that you might do. How do you balance between that and being spread too thin? Because you were saying it's arguably a strength to just focus on one thing. But I think there is strength in being very general, and maybe there's a larger market if you're more general. But tell me about that. Tell me about being more general, and how do you counter becoming too spread thin?
Yeah, well, we've been doing it for a long time, and so there's just a lot of momentum and software and tools we've developed. We're also we're pretty pro using open source. So we're big contributors to the ROS, like I mentioned earlier. MoveIt, the open source version, is out there. We have developed a new product called MoveIt Pro, which I'm sure we'll be talking about.
Definitely.
But because we've been around for basically 10 years now, we've done this a lot. We've seen it with a lot of customers. And so we've taken that experience and our work with a lot of big government agencies like NASA and Space Force. And we've just built out this, we've already built most of this. Like we have a huge library. We're counting over 160, and that's, I think, a conservative count, because some of them maybe are more like our customers. We've built something custom for our customers, but at least 160 of these skills and behaviors that are available. It's always growing. And so I kind of look at it as, I think the robotics industry, it needs a more common platform so that we don't keep reinventing the wheel. I imagine this is, again, similar to what you're doing in Intrinsic, but I look for inspiration often at the video gaming industry, actually. I've never been a video game developer myself, but of course they have video gaming engines. And when that was first kind of came out, my understanding from reading the history of this, it was kind of novel. It was most shops were building the whole 3D graphics, ray tracing, shading, all that stuff they're building each time on their own. And some groups like Unreal and Unity came along and said, why are we, having to do this? This is causing way too much costs, and it's a long time to get a new video game title to market. And of course, these shops had their own code that they were using for multiple games, but the emergence of these big platforms to speed up and improve the user experience and the tooling and make it so you can focus on your end application, whether it's certain storyline for a video game or it's a certain kind of combination of mobility and robotic arms and manipulation. And so, yeah, that's what we have available now. And we have a lot of successful case studies now of customers using our, I like to call it like a manipulation engine. It's equivalent to a gaming engine.
Cool. Okay. So manipulation engine, so I'm curious, how does that fit with MoveIt Pro? And can you tell me a bit about MoveIt Pro?
Sure. So MoveIt Pro is kind of the new commercial grade version of MoveIt. So I'm sure some listeners here are aware of this. MoveIt's I don't know if you introduced that one. It's very popular in research. My PhD thesis was based on it. I contributed a lot of my work to it. But there's been a lot of other great researchers, more accomplished than I, who have contributed pretty incredible algorithms for collision check and motion control, grasping and all of that. So that's available. PickNik's still maintaining it, and we still are contributing fixes to it, improvements. We just released the latest version for ROS to Jazzy. Did I get that right? So that's out. But MoveIt Pro is like, okay, MoveIt's for research, and it's kind of a benchmarking tool, comparing algorithms. That was the initial design. My mentor Yon Sukin designed it for that.
What does
And
that mean? So benchmarking algorithms. So you give them a similar task and you see how they do in
exactly, yeah. So
okay.
different labs like Rice University has developed a lot of kind of, they call it search-based planning algorithms, and those have gotten a lot of mileage. It's kind of our favorite, like maybe you've heard of RRT. But then other
Hmm.
labs did more like SBPL is a library that came with a different way. And then of course now there's new machine learning approaches to this. So there are different optimization algorithms, but there's a whole bunch of different ways of solving these robotic arm problems. And
Hmm.
for a while, at least, researchers were really interested in comparing and publishing papers saying mine's better than yours. And so I was totally guilty of that. I've published some comparison things, and MoveIt was great for that. And then when you want to actually deploy these algorithms to harden, reliable systems that have to have the infrastructure and containerization and like introspection, recovery, fault management,
Wow.
being able to do a lot of complex sequencing. That's not what MoveIt was built for. And so we kept building all that custom for our customers. And so I said, like, why do we keep doing this? These are like multi-million-dollar programs. It's taking customers a year plus, a couple of years to get to market, or sometimes they fail. They would underestimate how hard
Oh,
the
totally.
feasibility of all this was. And we've seen a lot of robotic startups who try to use robot arms kind of shudder or have to really pivot. Or maybe they get acquired, which is sometimes similar to shuttering, just kind of merging. And so our kind of thesis is like, okay, let's stop wasting all of this investor money on building the same thing over and over again.
Hmm.
And we've built a first in class application of like, okay, now you just drop in all these different algorithms depending on what you need. We can prototype something very quickly in like really complex physics simulators, and then work with you through the different phases. So like PickNik, we really love to get a quick prototype out with our customers, and that could be something that's used for market validation, getting that pilot out, showing investors, getting them excited about the vision. And these aren't just like concept videos. This is like we're using the full existing algorithm suite. We just haven't like done some of the like Six Sigma, like last mile reliability and like
Hmm.
deployment systems. So we can do that. But yeah, that's kind of where we're at today. So MoveIt Pro, I think you were asking about that. It's both a runtime and it's a developer platform. And so the runtime is the gaming engine part, and it provides like the core algorithms and a lot of the AI components. Of course, that's
When
a
you,
fun.
so I don't fully understand. When you say it's the gaming engine part, you're saying it's a metaphor to the gaming engine? Or is it literally has an engine for you to, like it's its own software suite in, I guess I don't understand the parts of it completely.
Yeah, it's the two parts. It's the game the runtime. It's kind of what goes in your released robot. So it's got the actual
Ah, okay.
some brains, and then of course there's a whole application layer that our customers build out. And to make it easy to build out their applications, we have a bunch of developer tools. So it's a whole user interface, and we're not an IDE. We're not trying to replace whatever developer environment you're used to for coding. So you can use VS Code or Eclipse or
Anything. Yeah.
anything. But we
Just
certainly
editing
have
text files. Uh-huh.
but we certainly have a lot of 3D visualizations where you can have multiple panes, different simulated camera feeds, real life camera feeds. There's a lot built around like teleoperation and recovery, so you can remotely help your robot out when you're going through your development stages. And then the core of it is as behavior trees, which is a very popular thing in robotics right now. It's kind of like a
Hmm.
state machine, but we allow our customers to build out very like complex, like multitask. We're going to do this and then that. We're going to drive over here. We're going to stop. We're going to survey. We're going to understand what's in the environment and then pick something, and we're going to go over there, put it down. We're going to like do a spraying operation, maybe a welding operation. That's enabled by behavior trees, and then the debugging infrastructure where you can have breakpoints and
Hmm.
kind of see some insights about what the robot's thinking, and maybe as you're developing it, something's not working right. I mean, that's like a lot of the problem of robotics is like understanding what the robot's thinking. It's a hard problem that like without good tooling, it's causing our industry kind of just to stumble.
Pain. Yeah, for sure. Yeah, I just interviewed Adrian from Foxglove, and like visualization is critical for sure. Okay, so you have the runtime. The runtime is the part that is actually running on the robot. So that's talking to it and executing your program. Then you have tooling. That's kind of the other big section.
Yep.
And so that makes it easier for them to write their code, introspect. And let's see, the debugging is very interesting. So actually, would you take me through what it might look like in like a cartoon version of using MoveIt Pro to do a simple application for this? Like what does it look like from the developer's perspective or the company's perspective? How does debugging work? Introspection in general? Like, give me a cartoon of that kind of thing.
A cartoon. So we have a handful of reference applications that we've built a lot of different things already that you can draw from. And so that's kind of the quick start is figure out what most closely resembles your application and then kind of build from there. And that's just useful because this isn't, this is still pretty low level and like, yeah, there is a drag and drop component of it that you can use, but we definitely encourage you to make your own code so you can do your own plugins, your own, we call them behaviors or skills.
Is it so when someone makes a program or behavior or skill, is it like one drop or one node in your behavior tree? Okay.
Yep. But you can make as many nodes as you want.
Oh yeah, and you can make your whole application from it. But that's the abstraction and where you give users access. I see.
Yep, and we've always been very pro ROS. So we're actually using just the ROS infrastructure. It's a ROS package. It's in like the ROS build system, and so you can easily pull in the ROS ecosystem. There's this concept of actions and services and all that. That's all built in first class.
It's awesome.
And so we're trying not to like change the developer workflow that a lot of people have learned in grad school and in college. This is kind of a de facto for development now, but we know there's a lot of rough edges. And I think with what Adrian's doing at Foxglove is it's really exciting, and we're really compatible with all those tools. So you can still launch RViz if you want. We have our own. We built a specialized visualizer that's really focused on robot arm trajectories and robot arm manipulation and debugging the understanding like how a pipeline of grasping and planning works. But you can definitely still connect to Foxglove and RViz, and we actually provide easy commands for that out of the box to like use those tools. And so we're trying to be very developer friendly. And so it could be from a high level, like if you don't know all that stuff, there's a lot you can do without it, but you might want someone on your team who has some like deeper computer science to add those extensions. However, part of our business model is that we also just build that for our customers often. So you can hire us to do those integrations as well, for sure.
Yeah, very cool. Okay. So you have the runtime. Yeah, go ahead.
I'm not sure I answered your question about this character, like this cartoon.
I have an idea of what you're doing. I was just meaning like, you have a specific task you want to do, then so you're grabbing one of these reference solutions for this kind of thing. You can try it, and then this is how our introspector works. And when you have some weird collision thing and your path planning is failing, then this is how we debug it. You're just writing it in your normal editor, like these kinds of things. So I can kind of see the process a little bit better.
Yeah.
But I mean, I feel like I have a decent understanding of it now anyways.
Like any like offline programming environment, you can prototype the whole thing in a physics simulator. And we've recently upgraded that simulator. We're not using Gazebo anymore. And that's really exciting because like Gazebo's always been really good about like AMRs and like, I don't know, like things that aren't as much contact dynamics, but we really found limitations in being able to like see the like manipulation of your fingers and your grippers on that. So Mujoku is actually the new thing that we've just launched.
Mujoku.
And so it's a pretty cool library.
Gazebo, and when you said AMRs, that's mobile robots, autonomous mobile robots.
Yeah.
But the Mujoku, so Gazebo is kind of like a higher level abstraction, as far as I understand, than a simulator. Like you can use Mujoku in Gazebo, but I guess you kind of went down a lower level and now you're using Mujoku more directly.
Yep.
And you were able to maybe visualize your paths and the finger grippers and all these things better with this like additional control you gain by going down to just using Mojoko. Is it correct?
Yeah, we can now simulate like really complex admittance control. And admittance control is a form of force feedback where we have like a closed loop and we can actually push on surfaces with a certain amount of force and certain vectors. And it allows for, like, just speaking at a little higher level here, like if we want to do a peg and hole insertion task, you can actually see the object deforming a little bit as we do like an insertion or an assembly. We can actually like push onto things, and like it's really exciting what that's enabled. So that when we deploy to hardware, which we do a lot, it's such a smaller gap because it's so much more similar.
That's super cool. Very interesting. Yeah, I've used Mujoko in the past a little bit. And I actually, like, funny enough, even coming from Open Robotics, I have very little gazebo experience. I have a little bit, but still a different, I'm mostly on the ROS2 side of things, but...
And we still do support gazebo. We can actually plug into any simulation environment. We have another one that's just like, we call it MockSim, but it's no physics. It's just kind of whatever
very
you tell it to do,
probably.
Yeah, whatever you tell it to do, it just does it magically. And then we have some integrations into NVIDIA Isaac Sim. So there's some advantages there with the synthetic data generation for ML. But we have some of our customers now using our platform for generating training data because for training models. So that's, I mentioned ML earlier, like we're more and more using that for all of our computer vision needs, but also for training models for other folks. It's been a big area of interest.
Very cool. Yeah, it's interesting, all the AI stuff and all the generating data and how that bootstraps things. Are you guys, so people are using you, why are using your new, what's your simulator called? Are you just calling it the PickNik simulator or using Mujoko?
It's just MoveIt Pro, and we have the development platform. And,
I see.
So
everything is under the MoveIt Pro umbrella in a sense. Yep. Okay. And so when you were saying that it's more hardened and you have more of a deployment, do you, like there's a lot of tough challenges there. There's a lot of infrastructure that needs to be handled. And you mentioned several things, but you're handling like things like deploying the code actually to the runtime so it can run it, and updating and like testing introspection. It sounds really cool that you have the teleop related behaviors. Just tell me about all the infrastructure that you have, because this isn't what I think of with MoveIt. MoveIt is kind of the research and also very good first way of doing manipulation in my head. And so we haven't talked actually, and since Studio has been released. I think it was very early days where it was more of a concept. But tell me about all the other infrastructure that you have around it and how it all works together.
Yeah, I mean, we've heard a lot of feedback that there's a lot of applications where they don't want it to be reliant on cloud. That could be for security reasons. We do work with Space Force a fair amount, and so they have like air gap requirements. So I think a differentiation from us and maybe like Intrinsic, which I keep bringing up, is there's really actually no cloud connectivity aspect. I love what the guys over at Foreman are doing. Jeff providing all of the fleet management. There's a couple of fleet management companies, of course, and we had an integration with them. It's still kind of there. We haven't been using it lately, but so if you want to do cloud connectivity, remote operation, we recommend you set up a VPN on your own, like whatever. We're basically network agnostic. You will leave that to you. A lot of companies have big opinions on that. We're just focused more on the harder algorithmic deep control engine aspect. Like we see just so many companies, they see a lot of like headlines about what the open source can do, and maybe I'm guilty of this. Like MoveIt open source claims to do a lot, but when you actually get into it, like we were talking about earlier, mobile manipulation, like there's a lot of shortcomings and limitations, and so we've been building out the things that we're missing to actually deploy. And so you can do it yourself. We've helped companies do it themselves. Just know that you're in for like millions of dollars of investment. And deploy your time to market. And then there's also like the long-term support maintenance where we're doing that for our customers now. We have a real-time support channel. Like we usually like share Slack channels with our customers. We have a QA team who's making sure that the quality's there. And we would just like a much more professional operation so that, for companies that aren't doing research, this is the thing we recommend now to like have a reliable, robotic product. And I think the industry needs companies like us, like Formant, like Foxglove, to kind of mature the tool set we have.
Definitely. Yeah. And it's, do you know Polymath Robotics?
Yeah, they're kind of focusing on the navigation problem. Is that right?
Yes. And the way I think of it is it's like behavior as a service kind of thing, where you communicate via like a normal REST API endpoint. So you just send a simple request and say, go here, or do something like this. And it will handle that kind of thing. So they're making it like behavior as a service is really how I'm thinking of what they're doing. And they handle a lot of the infrastructure for you. And that doesn't really, to my knowledge, that doesn't exist in the manipulation space for this kind of thing. But I'm hearing a lot of like echoes of what they're doing, which is kind of interesting in what you're describing with this.
Yeah, but we have a very high level Python API that if you want to integrate, maybe you have some existing code, you've been building out something, you can drop us into that, and like your overarching state machine or your overarching like controlling management, you can just like trigger our Python API and we'll take care of all the like the robot manipulation components for you. That is one way of using us. You can also use our user interface to kind of be the operational control panel, but we find that a lot of our customers, they don't want to use our UI, and we totally get it. Like you have a particular kind of operator or end customer who wants to see things with certain terminology and they want things simplified. And we've really developed a developer platform that's built in mind of like engineers and roboticists and what they need to see to build applications. But once the application is pretty much working, you need a different user interface to like whatever kind of automation program you have. And then we totally support that.
Yeah, it makes sense. So if you're targeting developers, you get the application up and running, you save a lot of engineering effort, and you handle a lot of the maintenance burden because they're just using your things. The team doesn't have to maintain it. The big reason with Polymath that I brought it up is they are doing like, it's basically they're helping companies with a lot of the undifferentiated work. And it sounds like you guys are too. Where it takes millions of dollars to set up all this infrastructure and companies just run out of money or make it, but it's like subpar because they had deadlines and they took shortcuts and things like this to get it working for one time. But then in the future, it's tech debt. And so you guys are in a position where you're able to spend more time in it. You're able to get buy-in from several different companies, and then that allows you to have the time and resources to really build something of quality. And so then it becomes a lot easier to just go with you guys because you save them time and money and work on the maintenance yourself, because that is the business in a sense. Yeah.
We do find like we work with a lot of corporate R&D labs, innovation groups. We work with a lot of robotic startups too, all sorts of organizations really. But with some of the robotic startups, we find that there's some organizations where they have a degree in robotics and they really want to just build it all in-house, and more power to you. But what we can really help companies with is like that short time to market is one of our big value propositions. Like, look, we've done this before. We have the components. Let us help you kind of assemble it in a unique way that's for your application. We can't like solve it just day one. There's usually some amount of configuration, and let's get these different skills in the right order, and like being able to like, we find that also companies, they always want they need different pieces of hardware. So they might, different vendors, or some of them build from scratch kind of their own in-house hardware. And we support all that. Our only requirement is that you have a ROS driver. Like if you speak ROS, we can drop in the rest for you. So that's a big advantage. We see a lot of companies that are kind of look like us. They don't have that hardware agnostic component to it. And then another value of us is like just managing the risks that you were kind of hitting on just now.
Hmm. Yeah, regarding all the like infrastructure that's required, and it's fundamentally not differentiating too, especially if you're doing on a startup and this kind of thing. I would imagine that like the investors would just prefer you buy something off the shelf so you can move so much faster.
Yeah.
Uh, Tell me about you mentioned having something like 160 capabilities or something like
Mhm.
this. What are those, and what's an example of what a capability is? Like, I mean, depending on how you draw your abstractions, that could be a lot or few, very few if, depending on where the abstraction is, where the line is for whatever you're calling capability.
Yeah. I'll just give you some high level categories of
Sure.
what our skills are in. So there's the classic stuff you think of when it comes to move it, and that's motion planning,
Yep.
um, Cartesian planning, global free space planning, being able to execute a trajectory, and all those kind of things. We have a lot built around like not just doing a position controller, but being able to switch between different kinds of controllers. And I might be losing people saying that, but there's velocity, there's force controllers. We can smoothly switch between those depending on what you need. So that's the classic
Cool.
stuff.
Mm-hmm.
And then a layer above that, you have task planning. And this is a little less intuitive for a lot of folks, but rather than saying move from A to B, then C, then D, and you just like hard code, this is exactly where you're going to be,
Mm-hmm.
we can actually tell the robot, like, here's a pile of boxes and we want them moved to the other side of the room. And we have to give them some structure to that. Like, they need to be stacked like this and that, but then you can kind of give it to a task planner to break that into all the sub steps. And we have different flavors of that. A lower level version of that is like a task constructor for motion planning, where it can add different intermediate steps. If you have multiple arms, it can choose which arm to use, things like that. And then a higher level is more semantic reasoning about to get to object A, you got to move object B off of it, and then kind of like going through a puzzle. So we've built out a lot of functionality there. We don't honestly use task planning as much. A lot of applications don't need that yet, but it's a thing that some of our more research programs, like when we work with like NASA, they want that for like fully autonomous space operations, for example.
Cool.
And then that beyond that, there's machine learning and perception, which is recognize all the objects in the scene, be able to reason about, we got to open this door, and here's the handle, and here's the hinge. And once you know where the handle hinges, you know how big the door is, and you can figure out the arc that you need to swing the door to open it. And then things like understanding where to properly grasp an object, like where's the wide point of it, where's the narrow point, how can I configure my arm to use that. So that kind of leads us in the grasping. We have a lot of different grasping algorithms. We do some vacuum suction, which is the most reliable form of robotic grasping, but we also support two-finger gripping, and in theory, we could support more complex than that. Then there's mobile navigation, so that's whole body planning, where we can actually, to reach something, we not only use our arm, but we're going to actually enroll our whole body. So the wheels, if we have a torso joint, if we have a lift joint, kind of planning all those together. And then lastly, something that a lot of groups maybe don't think about is user input. We have built out a pretty complex set of, we call it supervised autonomy, but it's not just teleop. It's like, let's say that you've deployed robots with arms into production, and it's running 99% reliable, and that's actually pretty impressive in this day and age of what robots can do. But there's always some use cases where something's out of the way and not where you expect it. We do have a lot of built-in capabilities to fall back to a remote operator, so that we don't dictate how that network is built for the remoteness part, but we can easily have a human say, okay, you're confused. Let me give you a little nudge about how to complete this task. And that's just kind of where we are today in deploying automation. And the goal is to get that fan out, which is a term for like how many robots to humans you need to get that really positive. So
what is fan? What is it? Is that an acronym, or what's the
fan out? I don't think it's an acronym. It's just like
fan out. Okay.
For one operator, one like remote robot human operator, how many robots can they manage?
Yep.
So this is more advanced than teleop, because teleop's usually one-to-one. In some of our customers, we've seen that you have actually two people overviewing a console screen for one robot. But we want to get down to where these robots are mostly fully autonomous, and then once an hour, once a day, a human has to drop in and kind of give it a help. But we built out that aspect as well.
That's really cool. Yeah, I've seen a lot of companies reinvent that. And then some companies make it like their core competence in a sense. Like Plus One Robotics is a good example in my mind of they do logistics, but when the robot gets a crazy package, like something I sent back from my Amazon returns, that's just like incredibly poorly taped together, then they handle it by having someone just like it like they have some operators sitting there, and then they get the request, hey, I don't know what to do with this, and then they can give it direction to handle. So you have something like that. I think that's going to be an increasingly big thing for robotics as a, like, it just helps with so many things to be able to quickly get a human in the loop. How are customers receiving that? How's that going?
Yeah, well, the irony of that is no one wants it because everyone wants a robot that's fully automated. They just want it to be so reliable that you don't need a human to drop in. So it's like not something that you really lead into of like, hey, we can make your robot so good that a human has to control it. You don't want to say that. It's like kind of the dirty secret, though, of a lot of autonomy that's in the market already. So my understanding of self-driving cars today, Waymo and Cruise, they all have big call centers in the background where when your car runs into a construction site, there's humans kind of guiding it along and helping it. And Plus One's a great example. My understanding, those founders are great, but they've been using that less and less. That's always the hope, is that
because you scale that fan or whatever it is. You fan out.
You want to go to market as soon as possible so you start getting customer feedback, you prove traction, you get your early revenue. It's important for getting the next investments and playing the whole VC game. But the value of this human in the loop is that you can do that really early and know that there's kind of a man behind the curtains, to use a Wizard of Oz analogy, to help just to kind of massage it along. And you gather data, and a lot of that can become training data to improve your models, to improve your software. But it's an important thing that gets overlooked, and that's something that we've built in from day one.
Oh, hell yeah. Yeah, I think I'm seeing more and more companies do it. And as you're saying with the data and things like this, I think it's just a clever approach, because as you reduce the number of humans you need per robot, that gets better and better. You get better margins for that kind of thing. You also learn more about your unknown unknowns for this kind of thing, so you could fit your problem better. So that's really cool that you guys have that. And so I guess you're not providing infrastructure for that necessarily, like on a network level, but you have the capability for someone to control a robot when they need. So I imagine it's like code running says, hey, flag this condition. Then it goes out to the network and says, hey, person, come help me with this. And then you have someone take over, do something. It sends the response back to them, and the robot executes it or controls it for a little bit.
Yeah, I mean, I think you could easily put in whatever network you want. We'd recommend just an SVN to start with. But we have the user interface built out. There's all different levels of recovery. Some of them are like pretty high level and easy. So for example, imagine looking at a camera feed of a robot's view of the world, and it's stuck and it's not sure what to do next. And you just use your mouse, you click on something, and our software can automatically then pick that object. Maybe there was like 3 options and I didn't know which one to go with. And that's a lot easier than using a game controller to teleop or using little joint controls. And we offer that too, but I just wouldn't recommend it as a fast way of doing anything particular. And there's other companies that are really looking at like the VR approach, where maybe you put on a headset, you have wireless hand controllers, and it's a one-to-one teleop. And we've explored that. We built out versions of that as well, but people get dizzy in those headsets, but we want to provide something that's smarter than that. So that's why we don't call it pure teleop, but it's like, just give it a little nudge.
Totally. Yeah, I think like from Plus One, like they just like you click and the robot figures out how to execute that. So they'll click on a package on a specific location and it will go and pick it up there, which gets the robot unstuck in the case it has like a broken box to pick up or something like that. Yeah. So that high level, just this is some guidance. And I assume like Waymo or some companies that are doing teleop at some point or human-assisted driving, I assume that they probably have them give more high-level commands because driving it at a low level would be pretty error-prone, I would imagine,
And
from
a lot of times, all you
headset.
need is to like have the robot say, "Okay, I'm not fully sure what to do here. And this is like the
Mm-hmm.
probability of correctness is low. So I'm going to present my proposed plan to the human operator and say, this is the trajectory I want to take. This is what I'm thinking is right." And oftentimes you can say, "Yep, that should work," and you just accept it, you approve it. But if it doesn't work, then you need to get a little more involved and like modify the trajectory, or maybe go more into a manual control. But just having that approval step can be very valuable when the robot's less sure. And that's something that we built out a lot for our work with NASA. I brought them a couple times, but they've been a great partner in all of this, and we're bringing that technology from very autonomous space operations, bringing it to terrestrial applications. But because NASA is a more conservative organization, they feel very strongly that there should be a human kind of overseeing it, and they want it to be autonomous, but also have a chance to intercept, interrupt, kind of like say go, no go kind of thing.
Since you brought it up a few times, what is the NASA work? Like, what are you guys doing? What kind of problem? How have you helped them?
So MoveIt first ran on the International Space Station a long time ago, 10 years ago, or over that, on the Robonaut 2 program. And so MoveIt was used for controlling this humanoid. In humanoid, it wasn't balancing on gravity, so it was more like a four-legged crawler through a low gravity environment.
I think of it like a spider kind of thing, because it's like the knees were backwards or something, because that was better for navigating.
It's really cool. Yeah, unfortunately, the program was pretty short lived. I think there was something to do with like SpaceX changed their payload, the size of the door, and we couldn't get the robot in anymore.
No way.
Something, and yeah. So other space applications is we're working with NASA on this, like creating a permanent lunar presence on the moon. And this is one of the big objectives, and it's good staging ground for the big picture Martian colony. So it's called, like in the NASA parlance, like Moon to Mars initiative.
Cool.
And we've got like Elon saying straight to Mars, but there's a lot of problems with that. So NASA's more like, well, let's prove it all out on the moon again before we go on. And so we're helping them with robots inside pressurized vehicles on the moon or on the future commercial LEO destination space stations, as well as robots that would be driving around on the surface of the moon with arms, picking things up, assembling, just kind of general purpose, helping astronauts do their job especially because like the first 10 years of the moon program is the astronauts will be there for a short period every year to like help out, but then the rest of the year we'll have it be more autonomous. And this is all published NASA strategy, but we're very involved with helping that program. And I also will bookmark a topic of we've been working on Space ROS to enable our technologies, our MoveIt Pro and all of that to work on the moon, because for things that go in space, there's a pretty high level of quality and software quality you want, because you can't just walk over there and unplug it. You can't have a human just plug in a keyboard into your robot and start debugging it if it goes down. It's a lot more high stakes. And so we've been hardening MoveIt Pro, not only for commercial applications, but for space applications. So that's what I mean by like MoveIt is good for research, and then MoveIt Pro is the hardened version. And I don't know if you want to talk about Space ROS at all, but I'd love to talk about that.
Sure. Yeah, I worked on Space ROS, actually, when I was at Open Robotics before we were acquired. But yeah, I'd love to tell me about Space ROS.
Well, we're hoping to continue your work. So, after Open Robotics has gone through these transitions that you know more about than I, we talked to Brian Gerke and like, hey, PickNik's very involved with space robotics now and with these different NASA and Space Force programs. So we'd love to kind of just help lead this open source initiative. So working with OSRF and Jeffrey Biggs, we were currently the chairman of the committee. And Space ROS, we've had a couple releases now. So it's essentially, think of it as like a special distribution of Ross too humble or Ross too jazzy. I actually forget which one we're on for Space Ross, but it's always going to be a little behind. It's not going to be the cutting edge. It's definitely not Ross rolling. For those who know what that means, it's like the latest
The
and greatest
bleeding edge version.
nightly. And so we're going to go through more quality checks. We're going to be a little more careful about what's included. And it's not done yet, but the overarching goal is to get it up to a higher safety standards, which is not only useful for space, but it's going to be great for medical, healthcare, surgical robots, maybe even automotive, even though there's like AutoWare doing great work there. So it's good for the whole ROS community because we've been really, and this is really your work and open robotics work. We don't want to fork it. We want to just push as much as possible upstream. Do you want to say anything about that?
Well, no, I mean, that was a great overview of it. Let's see. Yeah, I was involved on it for a few months. It was really fun, really cool work. And I was working with Michael Geronimo, who was leading it, and it was just so fun. But no, great summary. And I really agree with you that the applications, like it's not just limited to space. And I think one of the big things was all the certifications that we're trying to get it ready for. So that might mean testing things and specific ways of making sure that you're not leaking memory or, I don't know, just you're writing safe code in a sense. Those we're all working towards space certification, but as you said, it makes it a lot better for medical or possibly driving cars because those certifications are much easier to get because there's a good bit of overlap between, say, medical devices and space ROS, as I understand, or space certifications, or at least it's easier to prove to committees that might authorize it or whatever the certification process may be.
Yeah.
Yep. I'm happy you guys are maintaining it. Or
we just want a small NASA grant to kind of fund some of this work because a lot of it's been unfunded to date, just us kind of doing it as a side volunteer project, but it's certainly important to our future strategy. But we do have a small amount of funding now. We encourage anyone to get in the GitHub repositories. We have, I think, fortnightly meetings, technical meetings. And then every once a quarter, we have more of like a big picture meeting. And so we got all the big players, all the big government primes, like the Lockheed Martins of the world. They're coming to these meetings. Cool. And yeah, there's exciting momentum, but it's also difficult. Like this week we had a meeting for Space ROS, and it's kind of a dark week because there's been a lot of kind of failed space robotics programs. And I know we're really changing topics here from terrestrial applications, but you know a lot about Viper, I'm sure, and it just kind of got canceled.
For sure. I worked on Viper for probably 2 years or something like this. So yeah, it's a bummer. The Viper project, they were going to put a rover on the moon to go to the dark side and look for ice and water and this kind of thing.
Such a cool project.
Such a cool project. But yeah, it got scrapped. I think you're right, like in the last week or so, which yeah, bummer for sure.
And then we've seen that with there are these missions from NASA Goddard, OSAM-1, OSAM-2. We've hired some engineers from there. And those also have basically got scrapped. It might be in limbo land right now officially because Congress is slow on stuff, but it's looking bad for space robotics right now. And a lot of the reports coming out of like NASA committees on this is like, okay, the software budgets were overrun and it was too complex. And there just seems to be this growing evidence, to me at least, that software reuse, modularity, a developer platform, if you will, is really necessary for these programs to be successful. So that's what we've been really working on with NASA and what we're excited about. And I think these lessons are equally applicable to anyone who's into terrestrial robotics. Like we just see so many companies who get excited about applying cutting edge robotics to bathroom cleaning, hotels, restaurants, you name it, and then kind of getting smacked in the face with the reality of how primitive our tooling is and how building everything from scratch is maybe not the best strategy anymore. So we're excited to be part of this changing initiative.
Hell yeah. Yeah, I do think the building things from scratch, it's like even like when I started programming or when I was still in school, it's like, okay, ROS complex to use, I'm going to build my own. And then I did and got pretty far, but then what it was is I wanted something like RViz, and then it's like, okay, I'm starting to build my own RViz thing, and then it's like, okay, this is far too much work. Or then
Yeah.
Rosbag 2, it's like I want something recording all of the messages I'm sending across, and then at some point the pragmatic part of me wins, and I then learned ROS 2, and then thought it was a very good initiative for the community. But I feel like a lot of companies also do this, where they start being kind of purists and being, we don't need all the overhead. And then they see that there are reasons why people are using these complex, kind of prickly software. It's for some of the like ROS 2 stuff, where it's not that easy to set up and you need to be on a specific operating system and things like this. But there's still a lot of value there.
Yeah. I've always told people that you should use as much existing software out there to get your basic prototype together. There's a lot of options, paid and open source. And then kind of after you have that initial thing going, look at what part is really going to differentiate you and maybe kind of break off and like really optimize one piece of it, but don't try to bite off all of it, because only the largest tech companies can afford to do that. And even those tend to fail. I've seen a lot of big Toyota and Amazon and Google initiatives come and go, and they had an unlimited budget, but they bit off so much that still it didn't quite work. And so, I'd say that it's a funny thing that robotics does that I don't see as much in other industries, but maybe I'm just not in those industries.
I think to me, robotics, like, so I do a lot of side projects, and lately for the last like maybe 3 years or something, a lot of them have been web related because it's just so damn easy to make web stuff work.
Yeah.
But my thought is that robotics could become something like web, where we have very good tooling, very established infrastructure, like good players in very specific hard problems. Like in web, there's like auth and databases and all sorts of things where it's like, I don't want to learn how to do all that myself, like the hosting of it and whatever. But robotics, I think we are like where web was 20 years ago or 10, 15 years ago, something like that, where it's still painful to do things. And it's starting to get good enough that we're seeing companies like Locus Robotics that have, I don't think Locus has technical founders, or at least they started with people that are in the industry. I may be wrong about this, but
I mean, their CTO, he's a pretty big ROS expert, Sean.
Is he?
Yeah, I'd say he's a technical founder, but they're really smart bringing in the CEO who's like an industry knowledge expert. And I think that's the winning formula that you're getting at.
Yeah, exactly. Where you have people that are coming from the industries that they're trying to work in, doing these companies, and that's making it much more pragmatic. But I do think there's a lot of like rough edges relative to something as established as web. Like, and there's probably like 100 times or more web programmers than roboticists too. And there's probably 100 times more money also because of all the big companies. So that will move all those edges down. But I think it will change.
Yeah, because like in the web world, no one would try to just pull in all these, build all these components from scratch to the level that I still see robot companies trying to do.
Totally.
And there seems to be some kind of like belief that there's really deep value in the IP, in the robotics IP, the robotics algorithms. And I don't want to, I mean, I'll just say this generically. It's not to like insult any of our past customer base, but some of the customers we worked with, we sign all these NDAs, we have all these legal agreements, and we look at their code, and they've advertised it as something really valuable and secretive, and we look at it and we're like, oh, that's from textbooks. That's not something like that. Here's another version of it, like over here, that's very similar. So it's like there's, I think, a misheld belief that there's a lot of value, and really what I think, to Locus example, Rick, the CEO, like it's more about market knowledge, execution of penetrating that market, knowing what your competitive advantage is, and maybe that competitive advantage isn't the robotics side so much, but it's how you package the business model to work with that industry. Because there's still a lot of like resistance to robotics and automation from people outside of the average people listening to this podcast in robotics, I'd assume. And I think we forget that as folks who are really in this industry, that there's such expertise to penetrate, because PickNik's looked at specific industries that we wanted to maybe tackle. Can you still hear me? Can you hear me now? Yeah. So I got cut off for a second, but I think the winning model is like, knowing how to package robotics in a way that works for the business model and the needs of that specific industry. And even something as simple as like what to call the buttons in the UI. Like a lot of people don't understand what the word Cartesian control means outside of our niche. So like maybe you need, like, I hear some industries call it like endpoint control. It's a really silly thing, but like modifying those nuances can really make or break how successful your robotics application is.
Yeah, especially depending on who's using it. So if the people are not roboticists, that makes a lot of sense. Which probably most people are not roboticists. So that would probably make a lot of sense. Yeah, I'm seeing one thing that's very cool to me is that, so I've been podcasting, we talked about before the recording, I think maybe like 11 or 12 years now, RoboHub, SenseSync, now this. And I feel like the companies that I'm interviewing in the last couple years are doing this way better than any time before, in my experience. And I feel like I was talking to good companies before, but they are finding a market and finding a good business model. And it's more about how do you deploy in the market and stay and create value right away, but then stay valuable and maybe grow to something even more valuable. And it's so exciting, like these pragmatic founders that are starting companies and the great direction and traction that it seems like they're getting.
Yeah. And we say all this, and like, I think PickNik and myself were equally guilty of like, we focus just on the robotics. From day one, we've always done that. We don't have an in application that we're not just targeting like robots that make burritos really well and autonomously, right?
Yeah.
And so I'm not like, maybe not taking my own medicine here, but I think we're in a unique position where we're a really recognized brand of expertise for robotic arms. We've got really well positioned in the ROS ecosystem. And I do think the industry could use players who are providing the tools and
definitely.
the engines and the runtimes. And so I think we have a good head start here, and we want to keep doing that. But we really are dependent on our customers and our partners tackling those applications, and we want to enable them. So I actually think it's a good segue to talk about a customer that I mentioned to you earlier before the call.
Sure.
That we just published a case study with them. It's on our website. It's top of the list for case studies. So if you want to see the video, but Hivebotics is an example. So their CEO, Rashab, he's like really focused. He's more of a business person, focused on how do we bring like bathroom cleaning robots quickly to market. And so he's, instead of like spending years in software development and working on the research of it and technical risks, they chose to work with us. And so we're really honored for that. And we've been able to, in a matter of months, get them a working prototype. We got a video on our website of it driving through a bathroom and cleaning various sinks and toilets and stalls. And so I'm going to give a shout out to their success. And I hope that we can continue serving them really well. But that's kind of the model that we're looking at now, is founders who do have this very clear application and business model, who can get those early contracts and pilots with customers, knowing that there are companies like us who can just de-risk that whole technical side and do it really cheaply. It's kind of a good example of what we're talking about here.
Yeah, you have the expertise. It's similar to the problems you're already approaching. That's super cool. I wonder, so it sounds like one thing that'd be super cool, and this would be kind of funny as like a silly but potentially good business model, is like you do that kind of thing, but you take equity in the companies that you help for this kind of thing.
Yeah.
So it'd be like, you're like almost like a VC, but you take equity by helping them solve some of their technical risk. Like that would be pretty cool, I think. I don't know.
Yeah, never really considered that, but it's a good point. Because I mean, we are really like deeply embedded as partners with our customers.
And you help them move a lot faster, and you could be more long-term partners for this kind of thing. Like they could pay you, but also give you equity in a sense. I don't know. I don't know why I've been thinking about like the VC angle I've been thinking about, like in some past interviews, because if you have, say, way more information, or you can help them technically de-risk or something like that, there's not really a reason you shouldn't take advantage of that and get some of the upside if you help the company.
Yeah.
And so, like,
Huh.
one company I'm editing the interview now is Coop, and they do insurance. And during
Right,
the
right.
interview, it's like they have all of these metrics on the success or not of the company. It's like they could use that to be a very powerful VC arm, because typical VCs are not even, some are people in technology, but it's interesting if, like, you and your company, you are literally de-risking a problem, the technology for them. And that's one of the most valuable things. And that's one of the biggest risks that VCs are trying to get around. Like they need to look at the founders and the credentials and things like this. Whereas you guys can just be like, oh yeah, I'll do it. I'll de-risk it for you. Now you guys figure out the market strategy and we can kind of help you going forward. We can tell you that RRT is going to be way better for planning than some other algorithm or whatever it might be, and
Yeah.
show them the implementation. Just a silly thought. I don't know.
Yeah. Yeah, our current strategy is to come in really affordable at the start. And so we think we've got for what we're providing, really low price point. Like I'm talking like the cost of 2 months of an engineer, it's what we're charging essentially. And we can, but to do what we can provide you would take probably a year or two. So it's a huge initial investment, return on investment. And then as if and as we're, let's say as our customers are successful and they scale up, then we're looking for like a very small percentage of like return on that. So it's not equity, but there is some similarities, I'd say. But we want to meet projects where they're at. So oftentimes in the first phase of the prototype, the pilot stage, budgets are small, and you're really trying to prove to your higher ups or to your investors that this is a good thing to invest in. So we're trying to match that
Yeah.
budget kind of profile.
So it's a beachhead basically into the business. And from there, you can
Yeah.
do more work for this kind of thing. I wonder, just put it on your radar as like consider taking equity, especially in the ones that you think are super promising. Um, let's see. Okay. Super
Yeah.
cool.
I had a
And
thought
no,
about
go ahead.
Ross if we wanted to circle back a little bit before
About
moving on.
what?
So this is
Talking about Ross?
about Ross.
Yeah, go
Yeah,
ahead.
just a thought from earlier when I was bookmarked in my head is I'm seeing a trend in our industry as well where Ross continues, I think, to grow. Maybe it's slowed down its growth, but like it's still very prominent in all the robot companies that I talk to, at least. But what I'm excited about, and this is kind of weird to hear it say this, but like I think the scope of Ross is somewhat shrinking, and I think that's a good thing.
Hmm.
The Ross that first came to market in like 2010, it was attempting to do a lot of things. So people would think of it as the navigation and the motion control on RViz, the visualizer, and their simulator, and there's just like it's got everything. And I think the more proper scope of Ross, and this is a little bit I don't know, a hot take here, but it's the middleware, it's the message passing, it's the
Totally.
standardized interface, so that all these different actuators, motors, sensors, we want them all to be talking the same language, so that when you buy different components from different vendors, you can plug them all together. And then what I'm seeing in the industry is you're seeing these companies like PickNik and like others providing software components that provide those higher level capabilities, or you can develop yourself. That's always a perfectly good answer, but
Hmm.
I think that's a good trend for our industry, so
I
that
agree.
people are specializing in, and obviously open robotics is, they need to focus because they're not a huge organization post acquisition, and so that's kind of my take on that. And I still am a big fan of the middleware. I'm excited about they're changing the middleware maybe away from
To
DDS
Zeno.
and
I can't wait.
the
Yeah.
Xeno. There's a lot of good things happening there.
For sure. Yeah, I like your hot take. I agree with you. I think that it getting smaller is good, and the like I agree. We're giving more to the community, and we're seeing high quality maintainers like you guys that are working on things, or Foxglove and their MCAP, which helps with Ross Bag and things like
Yep.
this. So I think it's really nice that we can give back some of the parts that we were not maintaining as well, or they were kind of like edgy projects, and something in the community is coming back to replace them better. That to me feels very healthy. And I would add that in addition to just middleware, it's infrastructure, because we have a lot of stuff that all makes the community connect. So there's like the build farm and the way of getting all the packages that we have. There's all the testing related things we have. And these, as well as like the documentation and then like the discourse and things like this, that I think are a big reason that the community is as big and flourishing as much as it is, because we've set all that up. And it's almost like we get to play mediator now in some way and just have people use a lot of what we've built and maintain it and add features slowly. But I think consolidating what we actually have as our core value add is probably very smart and probably a very good sign for the maturity of the robotics community.
I agree. Yep.
Oh yeah.
Yeah, that was my only thought I wanted to bookmark. I think you were going on to a new topic.
I don't know. I was just talking. But I did want to make sure we talked about mobile manipulation. And because you've mentioned it, and it's not what I think of for MoveIt. I think of robotic arms doing stuff. And mobile manipulation, I know it's been technically possible to do, but I think you're supporting it more now as like a first party service or first party part of your application. So I'd love to hear more about that.
Yeah. So if for those who might recall the PR2 robot, that was the initial flagship robot at Willow Garage, the company that started Ross effectively. And so MoveIt was actually developed for the PR2. It had 2 arms and it had wheels. And I think people often forget that. But from the very beginning, MoveIt's always had some level of concept of a holonomic base, which is a robot base that can move in all directions. And I think that's been kind of lost. That was never fully developed, but it's always been kind of in MoveIt. But we're really making that a first-class focus. So we've done some open source contributions back to MoveIt to support that. And then we're also building out a lot more MoveIt Pro. That is going to, I mean, it's already out there, really allow for doing advanced planning with wheels. And one reason why we think this is a hot topic right now is humanoids are huge. They just got funded so much. Mm-hmm. And there's a lot of other folks who've been in the industry like myself who are a little more skeptical of the full craze of it. I think it's a bubble personally. What do you think?
I think it's like autonomous cars. I'm a lot of the same types of things seem to be occurring with autonomous vehicles or with humanoids as a human autonomous cars. It's like I was feeling like I'm reliving the same phenomenon when there was all the craze, and then it's like, why is this? Oh, like the dynamics, the hype is pretty similar. There are several things that are different, but I think that they're like, so for example, an autonomous car might be traveling at a speed where it's unsafe to have a glitch. And then you really need super safe systems, and that's very expensive. And a humanoid can just like pause and freeze, most likely in most tasks. So there are slightly different dynamics, but I think it'll be a little bit like autonomous cars.
And by that, what I'm hearing you say is like a long tail investment, and we're going to go through a couple waves of like, it's almost here and then it's not. We're going to get disappointed.
Yeah. So, and also I talked with, let's see. I talked with an investor at F Prime, and what he was saying is that from his perspective, investing in them doesn't really make any sense because there is no clear payoff date when the technology is ready for this kind of thing. And there's no clear market. So it's a lot like, autonomous cars had like the, robotaxi or whatever it might be. But I think humanoids, there's some use cases, but they're probably small markets. Like Melanie Wise from Agility Robotics convinced me that they're good for her use case. And they were doing Amazon tote delivery and things like this. And so there are some advantages to legs in that case. But I think that It's narrow markets that'll be useful. It's not the general thing, at least for the next several years, I think, like 5 or 10 years.
I have a contrarian view of this. One example I like to give is so humanoids are going to be more expensive. And of course, we're seeing prices drop from China and so forth, but I think they're inherently going to be more expensive hardware than like wheeled robot.
Yeah.
And
which are already super expensive.
Correct. But like, an observation I have is that most applications that can afford a humanoid robot are going to be already handicap accessible. Like, I don't think an average consumer can afford a humanoid in their house. And houses where you tend to have like multi-levels and steps and staircases. But like, with handicap laws, we have elevators, we have pretty flat surfaces. So
I just have a hard time. It's not necessarily true elsewhere, but the U.S. is the biggest market. And I think
it's true.
Are a huge market and very consumption like driven. Whereas like, I don't know, China, for example, is not as much of a consumption economy. These kinds of things.
That's true. That's a good point. That's a very U.S. viewpoint of mine. Like when I go to Europe,
things are way very different, not handicap accessible generally.
Yeah, and that's just for historical reasons. The buildings are so old. Okay, well, that's one view. But anyway, I guess I just think that the mobile manipulation's a little bit. It's certainly not in the hype right now, and that might be a signal that it's a mature technology. Not that like we don't see a lot of like applications out deployed yet for it, but I just think that's going to be ready much sooner than humanoids.
Totally.
So that's what we're focusing on. And the people have been working on this for a long time. The toilet cleaning Hivebotics demonstration I just talked about.
That's exciting. I want to check out the video.
That's all mobile manipulation. We've got a couple others. I mean, NASA's really into it right now with us, and a few more that we'll be announcing soon. So I just wanted to get that message out, is that like, I think there's still a lot of room for wheels that we're undervaluing.
Totally.
It's kind of my take.
I completely agree. I think a lot of the best companies that I've been talking to are companies that are just doing robots with wheels and having them like do some task, whether it be mowing or just driving around, sensing something, whatever it is, or some simple, I don't know, some simple task that's kind of comes with the vehicle. I think that my thought on it is that manipulation and mobile manipulation, particularly exciting, I suppose, is probably where just navigation was maybe like 5 or 8 or 10 years ago. And so I think probably the next wave of robotic startups that we're going to start seeing, Chef Robotics is a great example of a company that's doing manipulation, and it seems like they're killing it. My last interview was with them, the last one that was published before this recording. And
I know them well. I'm an advisor to Brigitte.
Yeah, Brigitte is awesome. But they're killing it. Like they're a company that I really would bet on. And they are probably the start of a bunch of promising companies around manipulation, in my opinion. And we're going to see more and more of them, most likely, in the next 10 years, say. Would be my thought.
Yeah, I agree. I'm really excited about all the applications that I think are being under considered for robot arms. And I see it a lot because we talk to these companies, at least in like kind of preliminary discovery calls on should we collaborate. There's so many out there that are emerging that maybe haven't come to market. But yeah, Chef had that big release, I think last week before, big announcement. So I've been following them for a couple of years. I'm glad they're kind of finally out of stealth.
Me too.
It's amazing what they've done with manipulation. And it kind of looks like a standard hard-coded manufacturing problem, but it's not. Like the different styles of scooping and the variable fillness level of the different bins and the different like viscosities and like material handling of different kinds of food. There's a lot of sensing happening there. There's a lot of dynamicism. And so I would call that a unstructured or a semi-structured problem. And there is some structure in that where the bins are and like roughly how deep the bin is. And there's a lot of things you do know, but it's a really impressive example of what can be done in this next wave of manipulation.
Totally. So I think we're going to see more and more of that. And I still do not think we're out of applications for mobile robots in general. And then some mobile manipulators, that's going to open up a whole nother set of robot applications. So exciting times, I think, ahead of us. Let's see. What do you, so in my thought, mobile robots, that's like, I don't know, say that in the last 10 years, that's really been becoming a thing, especially and you're seeing like outdoor mobile robots and things like this, like tons of applications there. Now we're thinking that mobile manipulation is going to be such a great opportunity. What are some of the challenges of why it hasn't been in more companies?
Great question.
So, and then also like what has been recently solved, and then what ones are looking like they'll be solved soon, and like how do you look at the space, I suppose, because you have a much better idea of this than I do.
I kind of want to just give more background for a second and say there's like kind of two categories of mobile manipulation that we consider. And we put this on our website recently. There's a page on this. But one category is whole body planning. And that's when you're moving your base, your wheels, and your arm at the same time. And that can result in a faster cycle time. So the robot is actually, this is what we do as humans. We might walk by, we're walking out of the door to get to our car or house, and you grab the keys on the coffee table, and you don't even stop walking. You just swipe it. And that's where we want to get to with robots. And we're working on that. We have some examples of that working. And then there's the more traditional way of you consider the navigation of your base as a separate step before you move your arms. So classically, you would fold up your arm into a stow position, let's say, and then you drive across the room. You kind of stop driving, and then you unfurl your arms and you grab something. That's kind of the classic way. And so we call that like navigation plus manipulation, kind of two separate steps. And the reason why I brought that up is because when you stop and then kind of you scan your environment, you use your cameras to understand things, that is easier because you have to recalibrate. Basically, you don't know exactly where you stop. The wheels have a lot of skid and slip, and there's just you're not exactly sure where you ended up. So you have to have a higher level of proprioception or self-awareness of where the robot is in a room with respect to a table or to an object you want to manipulate with. And so all that combines into a more complicated AI and algorithmic problem of understanding where you are. So that's part of it. It's just it's harder, especially if you're going to do it dynamically where you're driving and grabbing at the same time. Yeah, that's
hard for sure.
Yeah. And then the other side of it, I would say from a business perspective, is just it's a more expensive robot. And the more expensive your robot is, the harder it is to make the business case work. So we talk to companies all the time who they're like an innovation group, they're doing some analysis and we're working with them, and they come back from their executives, and after they do the cost benefit analysis, the ROI, it's doesn't quite work. The robot's too expensive and so forth. And so that's still what we're battling. So you said earlier that the bases, the AMRs, the AGVs, they're pricey. That does continue to be a thing that suppresses the application. Whereas a $30,000 robot arm, maybe it's 20, maybe it's less. That's a lot easier to drop in as compared to an $80,000 mobile manipulator or $100,000 system. So that's another version of it. So to sum it up, there's the cost of the robot goes up, and then the complexity of the software and the reliability goes down.
Definitely. Yeah. And you might need more expensive hardware to do that more challenging action. So then the cost goes up even further. Yeah. Well, I think mobile bases, that case you were mentioning where you just drive up to something and then manipulate it from mobility plus manipulation. There's a lot of applications there still too, and that's probably a bit easier. And also you can just have an arm, but I suppose it's probably a bit easier if it is mobile for it to move to whatever the problem is. But one thing that I was talking about with Machina Labs, what they were doing we were talking about robotic arms, and one of the things that came up was a robotic arm is probably, you were mentioning that they're cheaper, but it's an interesting way to do it that makes me think they'll be more valuable than humanoids in many applications is it's kind of the cheapest, most efficient way to move something in space. Whereas if you have the whole rest of the robot, you have a bunch of joints that aren't doing things, or maybe you're actively balancing and or you could just have a 6-foot robotic arm that is like motor link, motor link, motor link, for the full size of the arm. And then it can just move in the whole workspace.
Mm-hmm.
And it's a much more optimal form factor for doing a lot of tasks. And I can imagine that this is probably true, especially in the US, as you're mentioning, where there's very good handicap accessibility in most public buildings, which is probably going to be the place you'll see more robots sooner because they have more money versus an individual in like a home with stairs.
Yeah. Yeah. Yeah, and there's also we have a number of customers using just gantries, a linear rail.
Oh,
That's another
cool.
way of increasing your workspace a lot. You
Love
can
it.
hang them from a ceiling
Love
and
it.
kind of like make it still very accessible to humans.
Uh-huh.
So that's another way we add another degree of freedom to a robot arm. But
Super
I
cool.
personally prefer the wheeled version. It's a lot less impact on your physical building having to bolt a rail to it.
Yeah, ceilings are very exciting though for robotic applications. Like I'm seeing a lot. There's a few very good use cases, and they seem to fit really good, like security. But let's see. I wanted to so starting to wrap up. Where do you see PickNik? Like, what do you think for the next like 5 years? Where do you think you guys are headed?
Yeah. Love that question. So, I mean, we're all in on this MoveIt Pro platform. I started this podcast with, and pretty much going forward, all of our projects and all of our engagements with customers, they all are building on top of MoveIt Pro. And right now, I mentioned that we do some services. So, some of our customers, we're really working heavily with them to take the MoveIt Pro platform and apply it to their application. We kind of call those like turnkey solutions. We do a lot of that right now. But where we want to go is making this as self-serve as possible. And there's still more work to do there, honestly. I mean, we are a growing company. But we want to get to this point to where it's like a gaming engine where you just download it off the internet, maybe watch a few video tutorials, and just really equipping the next wave of roboticists to be able to do a lot more than they can do now. In a very reliable way that has a clear path to like deployment and a production system, even a flight system for space applications. So that's one dimension of where we're going. We want to just find more industries that aren't really being served by robotics right now outside of manufacturing, and really kind of change their mindset. So we do a lot of these like solution studies as a service that we have, where we go into like large companies and enterprises, and we really sit down with them over a series of meetings. We'll fly out sometimes and talk to them about where they want to go with automation. And they have these preconceived notions of like the limitations of PLCs and industrial robot arms. And we're
Yeah,
like, no, we can do way more than that. And they get
it's
really
great.
excited. And we really emphasize that we're not here to just like do it for you, but like this is a collaborative thing. So we augment their teams. They have their internal automation team. We give them the tools to like own it themselves. We just kind of give them a early push saying, all right, here's like a prototype and simulation, and then like let them run with it. And so that's kind of where we're going, of just like rethinking what traditionally we were limited to. Like an area that we're excited about, it's assembly. And that's, again, a little more manufacturing focused, but there's a lot of hard assembly problems that we think we have the building blocks to solve now that
Oh
weren't
yeah,
previously possible.
oh, that's awesome. Yeah, assembly is an awesome area. Okay.
And then I guess the
Well,
last thing I want to say is we want to have robots building moon bases, and that robot's not launched yet, but we're working hard on it. So I can't wait to be on a podcast in the future talking about how our robots have built a human habitat up there.
that's awesome. Hell yeah. Yeah, I can't wait for that too. All right. Well, thank you, Dave. This was a blast.
Yeah, thank you, Audrow. This is an honor to be here again, and thanks for all the great questions.
All right. Bye, everyone.
See ya.
So we've journeyed through the world of robotics with Dave Coleman from PickNik Robotics, and I hope you're as amazed as I am by the versatility and potential of robotic arms. We've touched on how they're not just for assembly lines or manufacturing anymore. They're becoming integral in dynamic and unstructured environments like farms, hospitals, and even space. Now, I leave you with a question. Where do you think robotics could make its next big leap? Could it be in home automation, disaster response, or maybe just in art and entertainment? Thanks for listening, and until next time, bye.